Hello and welcome everyone. I am Pradeep Chaudhary from Chanakya Tutorial and I will be guiding you for the mathematics section. As you know that we have started our first ever revision program, Marg Darshan. So in the Marg Darshan, what we are going to do, first of all, we will cover the entire chapter, in the one shot only. And after that, we will be also covering the PYQ session of the last 5 years or the last 10 years, So we are going to cover the complete PYQs, complete chapter revision in this Marg Darshan. For that, you have to do only one thing, just subscribe our channel and also hit the like button. If you will like the video, fine. I think we should start. First of all, let me introduce myself. I am Pradeep Chaudhary, as you already know, and I will just guiding you from the very basics. So if you do not know anything about mathematics, it even doesn't matter. If you're not started yet, it even doesn't matter. So we are starting from the very basics and we will move to the advanced level, right? The first thing, I will just you have to keep this in your mind. If you've not started yet, no problem. Just start it from right now and you have to score full marks in your mathematics and you still have the time, right? So Arambha Haprachan, I think we should start, right? Okay, I will just share my screen and we'll start, okay? Okay, guys. So first of all, I welcome you to this Marg Darshan batch. So the first ever revision program. So let's set off an thrilling journey and explore new horizons together. We are going to study together, right? So we should start, right? Before starting, we should know what is the syllabus. You know that many topics have been deleted from your book as well, right? They are not coming in your examination. So already that chapter that we are going to start, it is very easy chapter. The real numbers, of course, all the concepts like of the class 9th and the class 8th and the class 7th, right? But it is also very easy chapter. Now the CBSE has make it more easy, right? So what CBSE has done, CBSE deleted the topics that are some type of complicated topics, right? They are not that much complicated. They are also very easy, but now those topics have also been deleted from your syllabus. So now we are going to have only the two topics remaining over there. So let's see the syllabus over there. So the first topic is the fundamental theorem of arithmetic, statements after reviewing work done earlier and after illustrating and motivating through the examples. And the second topic is the proofs of the irrationality. But before moving to the topic, we should understand that we should have the knowledge that what is this chapter all about, right? You know that the questions may ask also from the another topics as well, right? So these are the two topics and I will guarantee you that these topics, after watching this video completely, you are able to score 6 marks in this chapter, because you know that this chapter will give you this only with this chapter will give you 6 marks in your examination. So fine, I hope it is clear to you, right? I think we should start. Before moving into the chapter, first of all, let's have a quick revise and the quick recall of all the concepts that we have discussed earlier. Like, what are those concepts? What are those concepts? Can you just tell me? Can you have just a quick revision? Okay, if you are ready, then we will have a quick revision of all the things, right? So fine. So you know that we have studied about the first of all the natural numbers, right? Like that whole numbers and all the things. So we should understand what is these numbers, and why this chapter is known as the real number. Why we are not saying it another number, right? Why the real number? Why the word real number is there? So we are going to have a quick recap of all the things, right? Fine. So first of all, let's understand about the numbers. So basically, if I'm just talking about the numbers, so first of all, there are the two types of numbers. The one is the counting numbers, right? So counting numbers, like I have to start the counting. I have just two more. I have the two things over there. So if you have just to start counting, you will start one, two, right? If you just four things, one, two, three, four. So basically, from where you start the counting, that is called the counting number. So one, then two, three, four, five. We are back to the nursery. We have done the time travel, now so on so on. So these are called the natural numbers basically. The counting numbers are also called the natural number. This is another thing. I hope it is very clear to you, right? Now what will happen, if we are going to include the zero in the natural numbers, what result we are getting after that? So if we are just including the zero over there like that, it will become the whole numbers. I hope it is very clear to you, right? So if we are just including the negative of all natural numbers, so what we are going to form it like -1, negative, negative. So the natural numbers, like counting numbers from the starting from the one, including with the 0, and also we are including the negative of the natural numbers. So this is the combination of all those, the natural numbers, the 0, and the negative of the natural numbers. Basically, this is called the integers that we've studied in the, I think, in the class 7th or 8th. Okay. So we are just recalling all the concepts so that we can make a brace after that, right? So basically, real numbers is like a kingdom. So what is that kingdom? We're going to see that kingdom. Okay. So these are the integers. Like if we're just writing out the 5 by 9 minus 3 by 5 minus 3 over 1, 4 over 3, 1 over 5. What are these? What are these? They have just a numerator, right? This is also integer. They have the denominator. This is also integer, right? So what are these? Ratio of integers, basically. We call the ratio of integers. The ratio of integers is called the rational number. Means rational number. So what is the rational number? All those numbers that can be written in the form of P by Q. P by Q form, where P is the numerator, Q is the denominator. Also, there is one more thing, that P is any integer and should be any non-zero integer. Okay, Q can't be the zero because the denominator can't be the zero. Why it is not like zero? Sir, why are you saying like that? That the denominator should not be like the zero. Okay, let's have understand by an example. Okay, just like suppose I'm writing 9 over 0. So I'm doing one thing over there. 0, I'm dividing 9 by 0. So how should I divide it that it will become the 9? Can it be the can does it will become the 9 ever? No, it will not become the 9 ever. Okay. And suppose if I'm writing 0 by 5, sir, is it possible 0 by 5 I'm writing the 0 by 5? So yes, it is possible. 5, this is the 0. So what I will do, I will just multiply it with the 0. Right? So if I will just multiply the 0, 5 into 0, I will get the 0 over there, right? So this is so simple, right? So means this is good. This is correct. There should be the 0 in the numerator, but 0 can't be in the denominator. I hope it is very clear to you, right? Okay. Now let's move. Fine. So these are the 9 by 4 and the 11 by 3. So basically we are seeing the two type of rational number over there. One is the 9 by 4, means it has some fixed value. It has some fixed value, right? It has some fixed value. 2.25, 3.66, 3 point. After that, something is not like we are not getting at any fixed value. Okay. It is like repeating itself. The digit is repeating itself. Okay. Fine. So this is called, now let's understand in a very easy manner that what are these things. Okay. Okay, so this is the 2.25. So we are getting a fixed answer. So we will call it, this is the terminating, right? And in this C 3.666. So basically it is the non-terminating, but there is a, after the decimal, the digit is repeating itself. So I'll call it, it is called the recurring, or we will call it the repeating, right? So basically the rational number are divided into the two types. One is the terminating. Okay, or another is the non-terminating and the repeating. Okay, and of course this topic has also been deleted from your like book, from your syllabus. So basically that like the terminating and non-terminating decimal expansions like is the final exercise, the last exercise of this chapter, but now it has been deleted, so you do not have to worry about that. Okay, just I'm giving you a quick revision of all the things, like fine. So if P is any integer and Q is any non-zero integer, then I will call the P by Q is a rational number. So P is an integer and the Q should be the non-zero integer as we have discussed. Okay. So decimal form of rational number. If we're just talking about what is the decimal form of the rational number, the rational numbers decimal form is terminating. First is the terminating, second is the non-terminating but repeating. Non-terminating, okay, fine. If it is non-terminating, we do not have any concern. But it should repeat itself. The digit should repeat itself. That is called the rational number. Right? Fine, it is very clear. Okay. Now see this example 11 by 3. See this 3.66 is equal to 3.6 bar. Okay. So this is also the way of representation. Okay. 3.666. So we can just write it within a single digit 3.6 to the power bar. Basically, it is called the bar over there. Okay. This is called what? This is called the bar. Okay. And now see this 4.914, 914, 914. We have to check up to the at least up to the three digits. That if it is repeating itself or not. We have to check it at least three digits. Okay. So 4.914914, yes, it is repeating itself. So we can call the 4.914 is the bar over there, right? Now let's find out that which are the rational number. See the first 0.048 bar, sorry, 0.04 and 8 to 8, the 8 then bar over there. Okay. So this is called the non-terminating but repeating itself because the 8 is repeating itself. So bar over the 8 representing what? The 8 is like repeating itself. Okay. Now see this. So that's why it is a rational number. See this 4.914. So 914 is repeating itself. So that's why non-terminating and the repeating. And this is also called the rational number. After that, see this 2.066. This is the terminating. This is the complete terminal. We are getting a correct answer over there. Okay. Like this number is neither terminating. Sorry, this number is neither repeating itself. So that's why it is completely terminated. So it will be called the rational number over there. Now see this 0.012254782. This is the non-terminating and non-repeating because you know that if you just find out any number after the decimal, it is not repeating itself. You can find out 2 is repeating, but only one time, not after that. It should repeat like a series. Okay. Like in the progression, it should repeat itself. Okay. 26538. Of course, this number is also non-terminating and also the non-repeating because we are not getting any answer. Okay, we are not getting any fixed answer. The number is like having like increasing or the decreasing, sometimes increasing or the decreasing by the digits and all, right? So number is increasing, right? So basically we can't get any answer. That we call the non-terminating and the non-repeating. So this is not a rational number. Now see this 2.6135302986.4. Of course, the number is not like repeating itself or neither it has been completed terminated. So we will call it non-terminating, non-repeating. So it is also not a rational number. So non-terminating, non-repeating, not a rational number. Yes, non-terminating, repeating. Now see this. This is the question. 270.253 bar. You have to just be careful at every time, whether it is rational or whether it is irrational, whether it is repeating itself or whether it is not repeating itself. Okay. Non-terminating, we do not have any concern about the non-terminating. After that, we should have to check that the digits are repeating itself or not. That we call the recurring basically. So if they are non-terminating and the recurring, we will call that it is a rational number. So we have just find out one thing that if there is a number, if it is terminating but repeating, okay, terminating and repeating. So basically, if it is terminating, yes, it is a rational number. And after that, it should be the non-terminating. It is also fine, but repeating, it is. So we can write it over here like in the next. So and see this. These decimal numbers are the non-determinating and the non-repeating. Okay, 0.0122547825. So these are those numbers that are non-terminating and the non-repeating. So we are just calling them the not a rational number. So what is the specific term given to them? Is there any specific term? Yes, there is a specific term. There is a special name given to is the irrational number basically. Okay, so that's why these are called the irrational numbers. So number whose decimal form is non-terminating and non-repeating are called the irrational number. Or we can say that those numbers that cannot be written in the Q is called the opposite of the rational number. Okay. So now let's find out the square root of the number square. Okay. So let's find out first of all the square root of the root 2. Okay. So root 2 is equal to what? 1.4142162 and the number is going so on, so on, so on. We are not getting any fixed value for that, right? So this is also called the irrational number because you are not getting any answer of that, right? Either this number is like it is the non-terminating, but it is not repeating itself. So it is the non-terminating and the non-repeating, or we can say non-recurring. See this root 5. Also, we are not getting root 6. Also, we are not getting any fixed answer. So the square roots of the numbers that are perfect squares are irrational number. Means that are not perfect square, sorry. The square root of numbers that are not perfect square are irrational number. We have to check if the number given to us is a perfect square. If it is a perfect square, so it will be called the rational number. If it is not a perfect square, we will call it is the irrational number. So it is the it is quite a trick of this. Okay, fine. Now I have just one more number, pi. So pi, some people call the value is equal to the 22/7. So we can write it in the form of p, and this form is the q. So it is quite written in the form of p over q. So why it is not a rational number? Yes, it is a rational. It should be a rational number, right? But it is not. Why? Because you know that if we are going to find the value of pi, the number will be the non-terminating and the non-repeating. Okay, the number will be the non-terminating and the non-repeating. So that's why we are using this 22/7. Because you know that at some extent it is true. Okay, at some extent it is true. And we have to do our calculations as well. We have to make the circle, but there is no perfect circle in this word. Still we are trying to find out the perfect circle, right? So we are not getting, because this is the non-terminating and the non-repeating. So that's why pi is also what? The irrational number. I hope it is clear to you, right? Now let's move forward. Okay, natural numbers are this: 1, 2, 3, 4, whole numbers 0, 1, 2, 3, integers -2, -1, 0, 1, 2, means the negative of the natural numbers, including the 0, and the positive numbers, basically the counting numbers or the natural numbers. So this is called the rational number, basically. Okay, these are the things that come in the kingdom of the rational number. Okay, so rational number like integer upon non-zero integer. And the what is another definition? Terminating. It should be terminating or non-terminating but repeating. Okay. Now another there is irrational number we have studied till now. So irrational numbers and the rational number. Okay, irrational number are what? Non-terminating and the non-repeating. So if we are making the kingdom, if we are just making it like this, okay. So if we are making it like this, like a table, we will find who is the absolute king. Of course, the chapter name, the real numbers are the absolute king. So these are all the sons of the real number, and real number is the father. Okay. So basically, real number is the son of the numbers, right? Because you know that the numbers that we've studied till now are called the real numbers. After that, in the class 11, we will study about the imaginary numbers or the complex numbers. That is another concept, basically. Okay. That is some other concept. Do not have to worry about that concept in the class 10. We have to just focus on the boards, and we have to just we have to gain the knowledge over here, right? So that's all. So that's all about the real numbers. Now let's see this. You can also see the like the over here over there. Fine. So these are the natural numbers. In the natural numbers, in the circle of the natural number, after that whole numbers. Okay, and including both, and also the negative of the natural number, you will find the integers over there, right? So root 49. So some people will get confused that root 49 is written over there. Isn't it an irrational number? No, it is not, because you can write it down 7 multiplied by 7, and if you are just removing 1 7 over there, you will find the 7 your answer. Fine. So that's why it is an integer. It is a natural number, basically. Okay. So because you know it is a perfect square, and we have studied in the rational section that those numbers, those who are not the perfect square, are called the, means the number should not be the perfect square. Then it could be the irrational number, basically. Okay. Fine. And the integers, then the rational number and the irrational number, they are pi, root 2, root 10, root 3, and all the numbers that non-terminating and the non-repeating. So that's all about a quick recall of all the concept. I hope it was very clear to you. Now let's move to the another slide. Fine. Okay. Now another concept that we have just seen the syllabus, and of course the most important concept, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay. So what does this fundamental theorem of arithmetic says? Okay. It is very simple. It is quite easy. Okay. It is just saying the normal things like, okay, but just we have just named it as a theorem only. Okay. Every composite number can be expressed as a product of primes which is unique. What does that mean? What does that mean, basically? Okay, let's have a quick difference of the composite number and the prime numbers. So prime numbers are those numbers which have only the two factors, one and the number itself. Okay, the only the two factors, one and the number itself. If the number has more than two factors, then it is called the composite number. Fine, then it is called the composite number. Prime number means a number, just like suppose given to just like take an example of the 3. So if you're just going to find out the factors of the 3, you will find there is only one factor, that is the 1, and another factor is the 3 itself. So there are only two factors over there. Okay, fine. So that's why the number that have only the two factors, 1 and the number itself, are known as the prime number, and the composite numbers are those numbers which have how many factors, which have more than two factors basically. Then it is called the composite numbers. Okay. Now let's move to the fundamental theorem of arithmetic. So what does the fundamental theorem of arithmetic say? Is saying it is quite very easy. If my speed is like fast, you can like go into the speed section of the YouTube, and just you can have just a slow button over there. Okay, so all the features are given to you. If my speed is slow, then you can also increase the speed. Okay, fine. So fundamental of theorem of arithmetic is all completely based on the prime factorization, right? So just like before moving to this, let's find out, let's have some examples. Okay, right? So before moving to the LCF and LCM, we are having some examples. Like suppose there is like a composite number that is 12. So if you're just finding out the prime factorization of this, okay, prime factorization of this 12, we'll find out 2, 6 times 2 is 12, 2, 3 times, and 3, 1 time. So you can write down the 2 multiplied by 2 and multiplied by 3. So basically, what are all these numbers? What are those numbers? Okay, so these are what? These are the prime numbers. Basically, these are what? These are the prime numbers. Okay, prime numbers. And this is the composite number. Basically, this is the composite number. Fine. So what was the theorem was saying? Every composite number, yes, this was the composite number, can be expressed as the product of primes, which is unique. So what is the meaning of this unique? Suppose I'm just taking another example. Let's take the another example. Suppose there is another number, composite number 16. So if you're going to find out the prime factorization of the 16, you will find out. I'm teaching from the very basics. Okay, you do not have to worry about anything. If you do not have the interest in mathematics, it is quite fun. Okay, mathematics is all about having some fun, all about having some experiments, right? So mathematics is all about the hit and the trial method, right? So 16 is the 2 8 times, then 2 4 times, then 2 2 times, then 2 1 time. So 2 times 2 4, 4 times 2 8, 8 times 2 16. So we can write down 2 multiplied by 2 multiplied by 2 multiplied by 2. So it has some product of primes. It has some other numbers, right? It is including, okay, another number. So that is the unique number, basically. The prime factorization should be the unique. So every number, every composite number can be expressed as the product of primes, which is unique, which should be the unique, which must be the unique, right? So that's all of this theorem, right? Now let's move to the HCF and LCM of this 180 and 54. But before moving to this, first of all, let's find out what is this HCF? What is this HCF? HCF. HCF simply means the highest common factor. Sir, we already know the full form. Why are you telling us we have to give our board exam? Just complete this chapter very quickly. I also know that, man. But still, I will know you. I will also let you know. Okay, don't worry. Highest common factor, because I have to give you the complete feel of the mathematics. What is the feel of the mathematics, right? Highest common factor. Highest common factor. Okay, sir, what is that meaning? Suppose we are taking, I will take the example in this. Suppose I'm taking the example. There is one number. There is one number 6. There is another number 12. So find the factors of this. If you're going to find the factors of this, not the prime factors, basically the complete factors. So what are the complete factors of this? 1, right? Of course, 1, right? 2, 3, and the 6, right? 1, 2, 3, and the 6. Fine. And if you're just finding the five prime factor, sorry, factors of 12, not the prime factors, just the factors. Okay. Fine. Because 6 is not the prime factor, basically. So 1, again 2, right? Again 3, right? Also, you will find the 4, right? And after that, you will find the 6, right? And after that, you will find the 12. Okay. 4 times 3, 12. 6 times 2, 12. 12 times 1, 12. And 1 times 6, 6. 2 times 3, 6. 3 times 2, 6. 6 times 1, 6. So all are these the factors of these numbers. Fine. Now let's move to the, now let's compare. Okay. 1. He will say the 1. The 1 is the common factor. Yes, 1 is the common factor. But is 1 the highest in both of these? No, 1 is not the highest. So 1 will say, move to the 2. There is my brother who is elder to me. Move to the 2. Now move to the 2, moving to the 2 after that. 2 will say, yes, this is common. Yes, this is the common. But is the 2 highest? No, there is one more highest than me. Who is the highest? 3. Okay, who is the elder of 2? 3. 3 is the common, yes. So if we are moving to the 3, 3 will say, no, I'm not the like largest. Who is the largest? 6. Because who is the highest? 6. So is the 6 common in this? Yes, 6 is the common. So we will find out the 6 is the common factor. So this we can call the 6 is the SCF of this. Fine. I hope this concept was very clear to you that what is the SCF and the LCM. I hope it is very clear to you, right? Just a minute, sorry. Okay. So this is called the SCF, right? It is very clear to you, I think, right? Now let's move to the another topic that is the LCM over there. So what is the LCM? LCM. LCM simply means the common, lowest common lowest common multiple. Fine. So lowest common multiple like that we have studied in the table, right? So let's see. Multiple. This is the multiple over there. Okay. So multiple like the table. Let's find out the multiple of this. Suppose there is one number 12 and there is like suppose there is another number 36. Fine. So we have to find out the multiple, right? So 12 times 1 is what? 12. 12 times 2 is what? 24. 12 times 3 is what? 36. And 12 times 4 is what? Of course, the 48. Now moving to this 36 times 1, 36. 36 times 2, 72. And so on and so on. Okay, and so on and so on. Okay, now let's see which is the common between them. Is the 12 common? No, 12 is not the common. Is the 24 common? No, 24 is not the common. Is the 36 common? Yes, 36 is the common. Is it the lowest? Yes, it is the lowest. So that's why they have LCM the 36. That is called the lowest. So we have find out the LCM of this. So what is the lowest between them? This is the multiple also. This is the multiple of 12 and this is the multiple of 36. Is it the lowest? Yes, it is the lowest. It is the common between them. Yes, it is the common between them. So this concept is called the LCM concept basically. Fine. I hope I know my writing is like very poor in this, but don't worry. My feelings are very good. So just understand my feelings, man. Okay. Now let's find out the SCF and the LCM of this. Fine. Fine. So SCF and the LCM. So 180 is equal to what? 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. Okay. So after that, if we're just going to take the common of this, we can also write the 2 multiplied by 2. It is not the better way if we are just writing the 2 square over there and 3 square over there and 5, just like 5 is only the one. That's why we have just like we can also write the 5 times to the power 1. Okay, if there is no power, we can also consider it as the power 1. 5 times to the power 1. 54. 2 multiplied by 3 multiplied by 3 multiplied by 3. And of course 2 we can also write it 2 multiplied by 3 cube over there. So 3 cube over there we can write out. So high SCF is what? Product of the, as we now let's move to the definition. Okay. Product of the least powers of the common prime factors of the numbers. Basically, this is the prime factorization method is the short trick to find the SCF and the LCM, because now we have to like learn all the tables, we have to find all the factors. And for the HCF and LCM, but the prime factorization is the short trick. First of all, we will just have the prime factorization of 180 and the 54. And after that, we will find the least powers of the common prime factors of the numbers. So what is the common prime factor? Common prime factor, I can just see there is only the 2, okay, and another is the 3. So this is the common prime factor between them, right? So we can find out the HCF of this. So this is called the 18 is the HCF, fine. So that's why HCF is what? The product of the least powers of the common prime factor. So what is the common prime factor between 118 and the 54? There is the common prime factor, that is the 2 only and the 3 only. So we have to find out the lowest power of them. So what is the lowest power of the 2 over there? 2 to the power 1. And what is the lowest power of 3 to the power square and 3 to the power 3? 3 to the power square, 3 to the power 2 is the lowest. So because 2 is lower than 3, right? So we can find out the HCF easily. Now let's find out the LCM over there. So LCM means product of the highest powers of all the prime factors of the numbers. Okay, you have to include each and every prime factor and you have to take the highest power of that. I have to include each and every prime factor over there and you have to take the highest power of that. How it is going like that? LCM is equal to 2 to the square into multiplied by 3 to the power cube and multiply 5. 4 times 27 and then 5. So this is called the 540. Now let's move to the logic over there. Okay. LCM, how we are going to find out the LCM? We have to include all the prime factors. So there are the, how many prime factors are there? Just a minute, I will let you know one thing. We can also write down 5 times. If there is no 5, so we can write the 5 times 0. Okay. 5 times 0, we can also write like that. 5 times 0 means the 1. Okay. So it is like very easy for you to understand it. Okay. So 2 to the power square, we have already written over there 2 to the power square, because we have to include all the prime factors basically. So 2 we have included over there, 3 we have included over there, and 5 we have included over there. And now we have to move to the highest power. What is the highest power between two them? Of the 2. The 2 to the power 2 is the highest power. This is the highest power. So we have written over there. And now moving to the 3 to the power 2, which is the highest power. 3 to the power 2 or the 3 to the power 3. So 3 to the power 3 is the highest power. And moving to the 5, which is the highest power. 5 to the power 1 or 5 to the power 0. Of course, 5 to the power 1 means only the 5 itself. So if we are just going to multiply them, we will find the LCM over there. Hope it is very clear to you, right? Let's move to the another slide. So HCF into LCM is what? 18 multiplied by 540, you are getting 9720. So there is another property, very important property. Of course, the 2 marker or the 3 marker question can come in your exam from only from this property. So HCF into LCM is what? 18 multiplied by the 540. You are getting the 9780. And the product of numbers, if you are just doing the product of numbers, means the 54 multiplied by 180. What you will be getting? You will also getting the same 9720. So of course, the fundamental theorem of arithmetic is very easy. And after that, we have also studied about the another property, that LCF, HCF of the two product multiplied by the LCM of the two like numbers, then it is equal to the product of those, right? Just like HCF of A comma B multiplied by LCM of A comma B will be equal to the A cross B, means the A multiplied by B. I hope it is very clear. Okay. Now let's move to the questions. So you have to find out how to express each number as a product of its prime factors. So there is one number 140. Okay, this is the question from your NCERT book basically. So we are also covering your NCERT, and after that we will be covering the PYQs as well. Okay, so you do not have to worry about anything. So 140. So what is the solution of 140? To 70. After that, if you're just going to divide 70, you will get the 35 over there. After that, the 35 can only be divided by the prime factor, that is 5, because there is none other prime factor that can divide the 35. Okay, so basically 5 is that only the prime factor that can divide the 35. Fine. Then 7. Fourth, because we have to after the 2 there is only prime factor, that is the 5, and after the 5 there is 7 also, but we have to start from the lower ones, right? So this is called the 7 times 1. Then if we are going to find out the prime factor, the product of this, we are going to, we will have the answer of this. 2 multiplied 2 square into the 5 into the 7. So it has expressed as the prime factors. Okay, product of prime factors basically. So in this solution, 146 is over there. And now let's move to the 146, like how we are going to express it into the product of its prime. So it is very easy, 278. And again, if we are going to divide, we get the 39 over there. And from the 3, we have to divide the 39. We will get the 13 over there and 13, 1, like that. Okay. Now this is for you. Okay, I will just have the solution, but you have to try it at your home. 3825, and you are getting the answer like this. 3 to the square and to the 5 square into 17. Okay, 3 to the power 2 into the 5 to the power 2 into the 17. Hope it is very clear to you. Now let's move to the another 5005. So if you are just going to divide it with the 5, you will get the 1001, then 7, 143, then 11, 143, then 13 times, then by 13, you will get the 1 over there. So you can divide it like that. Okay, 7429, again simple, 17. So, you know, that you have to just like, you will have to first of all find out by the 9, if it is not possible with the, like, sorry, you have to find out that you have to just make a list of all the primes. Okay, but how we can divide the 7429? If you're not getting divided, also divided by the 11, you have to move to the 13, right? But not, if it is not divided by the 13, you have to move to the, after that, you have to move to the 17. So if it is divided to 17, yes, it is. So then you will get the answer over there, right? Now this is question is also same. Again, do all the things like express each number as the product of its prime. So product of its prime means 2 times 500, then 250, then 125, 25, 5 and 1. So what is the product of prime you are going to do? 2 multiplied by 2, just you have to multiply all over the number that have been like in the prime factorization like this. We'll find out this. Okay. And solving on this, we'll get the 1000, right? 72, again, same thing. 36, 18 times, 2 by 9 times, 3 by 3 times, then 3 by 1 time. That is all. That's all. And if you're just going to find out, okay, now let's move to this property that we have already discussed in the, right? So we will just have a verify for all the things, that is this property true? So in this, first of all, we have to find the LCM and then the SCF, and then we have to verify the property that LCM into SCF is equal to the product of the two numbers. Let's move to this. We have to find out the LCM of this, 510. So we will do the, first of all, we will do the prime factorization of this, 510, and we will get like this, 17 times 1. And we can express it as the product of the prime factors, 2 multiplied by 3, multiplied by 5, multiplied by 17, right? And if we are going to divide this, like we are going to have the prime factors of the 12, we will find the 2 times 6, 3, and 3 times 1. Now let's move 2 square over there, okay, to the power 2, and then the 3 over there, fine. So SCF is what? 512. What is the SCF? Okay, we have to find out what the lowest. Okay, we have to find the least common, least. Okay, what is the least prime factor over there? 2. Okay, so that's why. And there is another common, that is a 3. And what is the least between them? Only the 3. 3 to the power 1 and 3 to the power 1. So it is same. So we can just take it any of them. So 2 multiplied by 3 is equal to 6. So because, you know, product of the common factors leads to the least power. We have to find out which is common, which of the prime number is common between them, prime factor, which is the prime factor common between them. So we have find out there is only the two common factors over there, means there are only the two prime numbers that are common in between, like common between them, that is the 2 and the 3. And you have to find out the least power, that which is the least power, which is having the least power. So we have find out the 2 from the 510 has the least power, and the 3 that is same in both, so it has the least power. So, and find out the LCM of this. LCM is also very easy. You have to include each of the prime factors over there. So each of the prime factor raised to its highest power. So 2 to the power square, then 3, then multiplied by 5, multiplied by 17, you will get the 1020 over there. Product of all the prime factors raised to the highest power, like that. Now let's do the verification. LCM into SCF is equal to the product of two numbers. So if you're just going to solve it, 1020 into 6, you will get the 6120. Okay, and if you're just going to the product of the two numbers, you will again getting 6120. So that's why it has also verified like that. So this question can also come in our examination, like by the 3-marker question or the 2-marker question. Okay. So this is again same, and you have to try it at your home. I will just have a quick. Okay, fine. So this is like that. Now we have to find the LCM and SCF by applying the prime factorization method only. Okay, we do not have to apply the our common method. We have to apply the prime factorization method. 17. So if you're just going to like have the prime factorization of the 17, you will get the 17 and multiplied by the 1 only, right? And 23 multiplied the 1 only, and 29 29 multiplied by the 1 only. So what is the highest common factor? So you can say that highest common factor raised to the least power, that is only the one, that is only the common factor that is common between them. There is only the factor, prime factor that is common between them is the one only. So you will find out the one is the HCF. And finding out the LCM of them, you will find out the each prime factor included in them, each prime factor. So first of all, we have the raised to the highest 17. So we will also include the 17, right? And after that, 23, yes, 23. And after that, 29, yes. Okay, you will get this answer. Okay, fine. 11,339, right? So this is the required answer. Again, similar question. 8 2 to the power 3 into 1, 3 square into 1. We can also write 5 square into 1. And after that, SCF of 8, 9, 25. Product of common factor raised to the least powers. The least power, what is the least power over there? We can clearly see the least power over there. First of all, we have to find out which is the common, which is common. So we are going to find out there is only the one common. There is only one common factor, that is the 1 itself. So we can find out the 1 is the SCF of this. Finding out the LCM, we have to like include each prime factor over there. So 2 is the prime factor. Yes, 2 is the prime factor, right? And highest power, 2 to the power 3. So 2 to the power 3. And then moving to the 3 square. Yes, 3 square over there. Okay, so highest power, only the 3 squares. We will include this. Moving to the 5. What is the highest power of that? 5 square itself. You will find out the 1 1800 is the LCM, right? Now again the same similar question, similar things, finding out the prime factor and all the things, right? And now this is the question. Okay, suppose you are giving
Yes. So, just sorry. We'll just have a break. Okay. So basically, you have to divide the 624 by the 52, and you will get the 18 bus over there. So, just like this was very easy because you know that we have to find the less number. So we have to find the SCF. We are getting the concept in our mind that the answer will be less. Okay. So that's why we have to find the SCF over there. It is very easy, right? Okay. Okay, fine. Let's move to the another questions, right? Find the largest number which will divide 445, 572 and 699, leaving the remainders 4, 5, 6 respectively. So you have to find the largest number. Okay. So first of all, what we have to do that it is leaving the remainders 4, 5, 6. So the numbers completely divisible of a required number are, you have to just, because you know these are the reminders over there. So for the question, for the like required number, you have to subtract these numbers. You have to subtract the 4, you have to subtract the 5, you have to subtract the 6, like you have to subtract 4 from the 445, subtract 5 from the 572, and subtract 6 from the 699. So that's why you will getting like this. Okay, the required number will be the SCF. Okay, because you know the largest number that will divide. Just think why we are finding the SCF over there. That you have to find the largest number that will divide 445, 572, 699. So the number will be smaller than all of them. Can the number be greater than the 445? No, it can't be, because if the number will be the greater than the 445 and the 572 and the 699, then it can't divide like three of them, and it can't leave the remainder 4, 5 and the 6 basically. So you have to find the SCF of. So SCF of, because you know the required numbers are 441, 567, 693. Okay, and the number that can only divide them should be lesser than it. So if the number is lesser than it, you have to find the SCF of it, highest common factor, right? So 567 doing the prime factorization and finding it all the things, right? So you will find the SCF of this 3 times 63. So it is called the 63. Now let's move to the another topic and the last topic of this video. See, this 16 and 36. So you can write it also 4 by 9, right? In the simplest form. So 4 and 9 are basically the co-prime number. What are these co-prime number? Those numbers that do not have any other factor, only like any other factor than 1. So two numbers having no common factor other than 1. So they do not have any common factor other than 1. They have only the common factor, that is 1 between them. So 4 times 1 and 9 times 1. So they have only one common factor, that is 1 itself. So basically, if A and B are co-prime numbers, then we can say they have no common factor other than 1. Let me check the recording is on or not. Yes, recording is on. Now we can move to the, okay, fine. So if A and B are the co-prime numbers, then they have no common factor other than 1. Example, 12 and the 17, 21 and the 22, 33 and the 40, and so on. So now let's move to a theorem. Okay, basically this theorem is very important for the upcoming questions. So let P be a prime number. So if there is P a prime number, so if P is dividing A square, then P is dividing A. Example, let's take an example. Suppose 2 is dividing the 8 square. Okay, 2 is dividing the 8 square. That means the 64. Yes, 64 is divisible by 2. Okay, fine. So 64 is divisible by 2. It means the 2 is also dividing 8. Let's take it in a very easy way. Suppose there is one number 9 square. So it is divided by, the 9 square is what? 9 times 9, 81. So is it divided by 3? Yes, it is divided by the 3. Right. So like 3 can also divide 9. Yes, 3 can also divide the 9. So this is the simple theorem that we have to use in our upcoming questions, right? Now let's move. Simple. This is the important question that will definitely come in an examination. Prove that root 5 is irrational, or prove that root 2 is irrational. So if there is a question like that, prove that root 5 is irrational, then what you have to do, you have to just find out, we will just have the contradiction of like of ourselves basically. So first of all, just if there is like root 5 is irrational, first of all we will consider it as the rational. Okay, if it is not irrational, it will be the rational, right? If it is saying irrational, we have to prove it is irrational. Okay, then if it is not irrational, then what can it be? It should be the rational. So we will consider it as the rational, and if all the things are good and well, then we will consider it is the rational. And if we are just contradicting our own fact, no, it is not, it was not rational. So what kind it could be? It should be the rational number, irrational basically. So prove that root 5 is irrational. There are fixed step in this. First of all, we have to find out. We will prove it by the contradiction method. Okay. So let us assume that root 5 is a rational number. Let us assume that we will assume, right? Root 5 is rational number. Okay, if root 5 is not rational number, then we can easily say that root 5 is irrational. So we will have just the contradiction of that fact, that what we are assuming is completely wrong, and that's why root 5 is irrational. So how we are going to do that? We have a look over that. Okay, so root 5 is, if something is irrational, then it should be written in the form of the p by q, or we can say that it should be written in the form of a by b basically. So rational numbers a by b is a comma, like b is not is equal to 0, and a and b are the core prime integers. So root 5 is equal to a over b, we can easily write. So there is the co-prime integers basically. Okay, they should not have the common factor other than 1. Okay, so a by b. So if we are just going to multiply the root 5 and the b, we will get root 5 into the b, right? We can also do the multiplication over there. Okay, so root 5 into the b, we will get the a over there, right? So can we? So now we have, what you have to do? We will have just the square for the both the sides. Okay, so that the square root will be removed from the left hand side basically. So now 5b square is equal to a square. That is the first step. So if 5 divides 15, if 5 divides 15, that's 5 into multiplied by integer will be also equal to the 15, right? If the 5 is dividing the 15, then it simply means the 5 divided by an integer. Like what that integer should be, the 5 times 3 is equal to 15 basically, right? So for that, like that, right or not, 5b square is equal to a square. 5b square is equal to a square means 5 multiplied by an integer, 5 multiplied by 3 is equal to 15. It is simply meaning the 15 is divisible by 5. Like that, 5b square is equal to a square. Okay, let me have a better explanation. 5b square is equal to a square. It simply means 5 divides this a square. 5 divides this a square, right? It is simply meaning the 5 divides the a square. Okay. So 5 divides a. So if the 5 is dividing the a square, it simply means the 5 is dividing a, as we have already like seen this theorem in the last slide. Okay. So 5 divides a. So let a is equal to 5c, means if it is dividing the a, it will getting the another number c. Let me explain it in a better way. Suppose 5 is dividing this a, then definitely we will get some c over there, right? That's why we can add the 5c. So a is equal to 5c over there. Okay. So now substituting this value of a in 1, right? 5b square is equal to 5c square. 5b square is equal to 25c square. Now what we have to do? We have to just divide the both sides by 5. Okay, we will have the divide by both sides by 5. Okay, means the b square is equal to the 5c square. If we are just dividing the LHS by 5b square by 5, we will get the b square. If we are just dividing 25c square by 5, we will get the 5c square over there. Okay, so it simply means 5 is also dividing the b square over there. So it means the 5 divides b as well. Fourth. So from the third and the fourth, we get, from the third and fifth, we get a and b have the common factor, that is the 5. If a is also divisible by 5 and b is also divisible by 5, means 5 is the common factor between them. So if 5 is the common factor between them, this simply means these are not the co-prime numbers. So our method was wrong. Our approach was absolutely wrong. So approach means these are not the co-prime factors. So if they are not the co-prime factors, that's a root 5 is not a rational number. So if it is not a rational number, then it will be called the irrational number. So like that, we can write like that, root 5 is an irrational number. Now this is the another type. 3 plus 2 root 5 is irrational, right? So what you have to do, you have to just, we have already like proved that root 5 is the irrational. We have already proved in our last slide. Root 5 is irrational. So we will use that root 5 is irrational and we can easily find it like that. Okay. So we can write down, we will prove it again by the contradiction method. Let us assume 3 plus 2 root 5 is a rational number. First of all, we will assume, okay, if it is not irrational, then it will definitely be the rational over there. So 3 plus 2 root 5 is a rational number. Rational number is equal to a upon b. B is not is equal to 0. And a and b are the co-prime integers basically. So there exist co-prime integers a and b. So 3 plus 2 root 5 is also equal to the a over b. If something is rational number, it could be written in the form of a over b. So just like by doing a over b, the 3 is in the left side. If it will be moved to the right hand side, it will get subtracted from the a upon b, right? A upon b minus 3, we can write it like that. So 2 root 5 is equal to a over b minus 3. So now solving all these things, you will find the a minus 3 by b, a minus 3b and the 2b over 2b. Okay. And suppose a is also the integer, 3b is also the integer, and 2b is also the integer. Okay. This complete expression is of the integers basically. So if this is expression is of the integers, so integer upon integer upon non-zero integer. So 2b is the non-zero integer basically. And a and b are also the integers. So integer upon integer is equal to, because b is not is equal to 0 now basically. So if the b is not is equal to 0, so 2b is the non-zero integer. So integer upon non-integer. Remember the first slide. Integer upon non-zero integer. So basically it is called the rational basically. So it is the rational number. It will be equal to the rational number. Okay, yes or not? So if this is the irrational number, then root 5 will be the is equal to the rational. So if the root 5 is rational, how we can say the root 5 is rational? We have already proved that root 5 is irrational. So if a minus 3b upon 2b is rational, it simply means root 5 is also rational. So root 5 we have also proved that. This contradicts the fact that root 5 is irrational. Okay, this is contradicting. Okay, like the root 5 is rational. It is also like if the right hand side is rational, it simply means if it is equal to the left hand side, both of them should be the rational. So that's why they can equal like that, right? So we can say that 3 plus 2 root 5, our assumption 3 plus 2 root 5 is a rational number is wrong. So it is the rational number. Now you have to solve these questions at your home. Root 5. Again, we will have this. Just a minute. Again, we will have the same approach. We will first rationalize the denominator. In this question, we will have the first rationalize the denominator and then move to the another. Root 2 by 2 is rational. Let's first of all, we will assume it like the rational. Then we have like if there is something rational, we can write it in the form of a by b or the p by q form. Then a by b like 2a over b, and then 2a and the b are the integers. And if they are the integers, then they are simply the rational. And the rational should be equal to the rational, not the rational can't be equal to the rational basically. But root 2 is a irrational number, right? So it is also contradicting the fact. Our conjunctions are wrong. And just try it at home. Let us assume 7. Okay, it should be in the form of a by b. So if let us assume, first of all, we will assume the same thing, that it is the rational. So if something is rational, we can write it in the form of the co-prime integers. So a over b root 5 is equal to, and then we will move to the 7 into the denominator basically, to the right hand side basically. And now a and b are the integers. So it simply means that the another side is what? Another side should be the rational basically. If they are the integer, if there is the combination of the integer, then it will be called the integer upon the non-zero integer. It will called what? The rational basically. So the rational should be equal to the rational. Rational can't be equal to the irrational because root 5 is already irrational. So it simply means that if there is this side, if the right hand side is rational, then the root 5 is also rational. But root 5 is not rational. So root 5 is irrational over there. So our assumption was wrong, and you have to just approach the same thing over there, right? So that's all. And you can scan this QR code to access all the materials and the worksheets. And because I'm also providing the PYQs and the DPPs of the like over the last 10 years, so that we can discuss. And in the next class, like after completing all the chapters, Like after having the quick revision of all the chapters by the concepts and all, we are also solving the PYQs of the last 10 years, not the 5 years. We will solve the last 10 years basically. Okay, so that we can score the maximum, not the maximum, we can score the full marks. 80 of 80 we have to score in our examination. So that's all from my side, guys. If you have any doubt, then just post it into the comment box. I will definitely reply it. So that's all from my side. Thank you and Jai Hind everyone. Thank you very much. And also don't forget to subscribe our channel and hit the like button, because if you just subscribe our channel and hit the like button, we are also getting some motivation that you guys are doing something for us, we should do hard work more, we should do more hard work for you. Okay, so that's all from my side. Thank you very much. Have a nice day.